Okay. Welcome to the video thing. Right, question 1. It's going to be great, isn't it? Evaluate 27 to the minus 2/3. Right, well we're going to unpick the stuff that's going on with the powers and stuff here. We've got a third as a power. That means the cube root, doesn't it? So the first thing we're going to do is we could use that to start with. That means the cube root of 27 is going to be 3. So it's 3 to the minus 2. The minus sign in the power means it's 1 over. And 3 squared is 9. So the answer is only 1 mark. The answer we should have got to is 1/9. Good start. Write 7 root 7 in the form 7 to the n. Well, this is just using our knowledge of indices. 7 root 7, that's 7 to the 1 times 7 to the half. And we know that when we multiply things, we would add the powers, so that is 7 to the 1.5 or 7 to the 3 over 2. It doesn't matter if you wrote 1.5, but 3 over 2 is slightly nicer, isn't it? Good start. Another mark to 7 to the power of 3 over 2. And we're on to question 2. Express 4x squared minus 8x minus 1 in the form 4 brackets x plus a all squared plus b. Again, it's up to you whether you want to do the comparing coefficients method or the other way of doing that. I'm going to do it the other way, the way where we think of that as being 4 brackets x squared minus 2x minus 1. A half of my coefficient of x is 1. So this is going to be 4 brackets x minus 1 all squared. Now, if I multiplied out that bracket, I would end up with a plus 1, but I would end up with it 4 times. So I need to take away that 4, and I've already got a minus 1 there. So the answer is 4 x minus 1 all squared minus 5. And we notice here, don't we, that even though it was plus a and plus b, it doesn't matter that we've come up with negative values there. That's quite a lot of marks for that, isn't it? 4 marks for doing that. Question part 2. State the coordinates of the vertex of the curve. Well, this is just a thing we've done quite a lot of interpreting what's here. If that's the point, if x was 0, that would give it as its minus value. Sorry, if this was 0, we'd get the minus value, the least value. So x has to be 1, doesn't it? That was the point. And if x is 1, that's 0. 4 zeros, take away 5. These are the minus 5 as our other coordinate. Give yourself a mark for each of the coordinates there. And that's question 2. On to number 3. Solve these inequalities. Well, the first one is very kindly factorised for us. And I've been encouraging you to draw a graph of this kind of thing. This would be a quadratic that crosses at -2 and -4. So let's do a quick sketch of that. Something like that. It doesn't matter that our scale isn't brilliant there. And we want to know, when is it greater than 0? When is it above the x-axis? So it's those bits which represent these bits of the curve. So we want x to be less than or equal to -4 and greater than or equal to -2. And remember, this has to be 2 distinct regions that we're describing here. We can't wrap this up as one answer. Part 2. This one, we can't deal with it yet as it is. We need to write it as the form of a quadratic first, in our ax squared plus bx plus c. So let's take everything over to the left-hand side. It'd be nice if we could factorise this, and I don't mind how you want to go about doing this. Let's kind of just go through those steps really quick. -6 x squared, that would need to be what? Minus 6x and a plus x. That would work, wouldn't it? So if we try and factorise it with that, 2x squared minus 6x plus x minus 3, we've got 2x as a common factor of those two terms. we've got just a factor of 1 of those two terms, haven't we? So it works out as being 2x plus 1 times x minus 3. And you may have got to that quite a bit quicker just by looking at it. We now can draw our graph again. Quick sketch, minus a half, plus 3. So the graph goes like that. We wanted to know when it was negative. So that's the bit where it crosses, where it goes underneath the axis. So we're looking for this bit here. And so this one, the answer looks like that, minus a half to 3 is the region we want. Okay, the next one. Oh, did we even manage to find this on the page? So well disguised with this stealth quadratic. Okay, our way of doing stealth quadratics then is to identify the term that appears with its power doubled. So we're going to say that t is x to the third. We're going to do a substitution there. T squared, of course, would be x to the 2/3. So we've got t squared minus 7t plus 6 is 0. It will factorise quite nicely. What was it? Minus 6 and minus 1. Well, so we get t is 6 and t is 1. Aha, but the question wasn't about t, the question was about x. So that is x to the third is 6. And x to the third is 1. And so our final bit, we've now got to undo that. If x to the third is 6, that means you cube rooted x to get an answer of 6. So x must be 6 cubed. And x must be 1 cubed. And they are our two answers. I did just do 6 cubed correctly, didn't I? Yes, good. There we go, 5 marks. You're looking at 2 marks at the end here. A mark for getting 6 and 1 as the answers, a mark for factorising it, and then probably a mark for doing the substitution. We're kind of getting to that point. And we're on to question 5. Mammoth homework this week. Here we had an S1 paper. We've got 200 candidates take each of 2 examination papers. The diagram shows the cumulative frequency graphs for their marks. Estimate the median mark for each of the papers. So there are 200 students, so that's a big N. So we just need to think about the 100th one as the one that we're after. So you might take a ruler and draw onto your, oh, that's right, isn't it? That. And then draw, oh, I've missed. Draw down, and, oh, everything is suddenly going wrong, technically, for Dave. There, I'm ending up with 38, I think. Does that sound about right? That's my value. So for paper 1, I've got 38. This is for part 1. And for part 2, this is going to go wrong again, isn't it? Oh, man. Did somebody just say yes then? A little bit, really. Look at that. That's looking very... Oh, we've missed by some distance. Does this look slick and professional? There we are. Do I believe 61 might be the right mark? Do we agree with 61? So paper 2, we've got 61 for our median. State with a reason which of the 2 papers was the easier one. Do students tend to score higher on an easier paper or lower? Higher. They score higher, don't they? So we would expect the one with the higher median to be the easier paper. So the higher median was paper 2, so we're going to say that our answer for part 2 is paper 2 because the median is higher. And that seems like a reasonable answer for that. It is suggested that the marks on paper 2 were less varied than those in paper 1. Use interquartile ranges to comment on this suggestion. So we've now got to find the interquartile ranges for the graphs. If there are 200 candidates, then that means we're looking at 50 and 150 as being the values. So let's look across from 50. This is about where my line's going. And let's drop down the values from there. I can't even see where this should be. Maybe better. Maybe there's a better way of doing this, what do you think? Oh no, that's all going wrong. Stop it. Right, okay, we're on to it again. There it is. Right. Do we reckon 25 looks about reasonable for the lower quartile for paper 1? And the upper quartile is, am I persevering with doing it this way? Or is this just madness? Oh, I've missed again. How does that look? 55? So we've got an interquartile range of 30. If we do the same things for paper 2, here it comes. Missed again. There we go. We're at 46. Does that look about right for the lower quartile? Upper quartile, this one I'm going to get perfectly. Watch. Oh, I missed. What do you think about there? Is that about 71? 73, I said. Oh yeah, it is. That would be 73. There we go. 27. Oh! There's not a lot in it, is there? I would say those interquartile ranges are pretty close. It suggested that the marks in paper 2 were less varied. Well, they are. It's only just. So let's say paper 2 marks were slightly less varied. I think you probably get away with arguing that there's not a lot in it as well as an answer to that. So either one. That's it. That was all of this week's homework, and that's maths.